Yes.
So what is Kubernetes? We have discussed in detail what Docker is. Now, in Docker, we have to do, we write our YAML files, we create our Dockers, but there are still a lot of limitations there. So Google introduced Kubernetes as an open source container orchestration engine. It automates the deployment, it supports auto scaling, it supports high availability, and it is deployed in cluster. And the beauty of cluster is it is a self-healing cluster, and you can have as many pods or containers for your app available, and the spinning the containers is way more easier than Dockers. So again, as I was telling you, Kubernetes offer high availability, scalability, disaster recovery. Now, Kubernetes has a lot of components. I am discussing some major components only, like pod, service, ingress, config map, secret, replica set, deployment, states, and volumes. And you have to absorb it very thoroughly. In Docker, the smallest unit was our container. In Kubernetes, our smallest unit is pod. We don't interact with pod directly. And actually, pod is an abstraction layer over container. We will discuss it everything in detail, and we can come back again. So we have our pod, and inside our pod, we have our container. So it is just a representation of the container with few more things attached to it. Each pod has its own IP address, and it's the private IP address. We all know that. And in Kubernetes, the pods die, and they are died and created for load balancing. Even the pod can die just that I have more node on this cluster or in this physical node. So I should run this pod on some other node. So this pod is destroyed here and created there. In VMware or other platforms, when we were talking about the virtualization, we had an option to migrate the VM from one host to another host. So there is no vMotion concept here. The pod is destroyed at one place and it is recreated at other place with the same state. So another thing is, if your pod is crashed somehow, so Kubernetes always observes the state that how many pods should be there, and if one of them is crashed, it will recreate that again. So again, as I was telling you, Kubernetes is a self-healing cluster. So every pod is attached with an IP address. But if the pod is destroyed and recreated, the IP address is changed. And let's say this is our database. This is our database container. If the IP address of a database container is changed, your application will not connect to your database, because we know that our application communicates through the names or IP addresses. We have only two options. You connect via name, you connect via IP address. And if the IP address is changed, you cannot connect to a pod. So we attach a service to our pod. This is another component. So let's service is like a load balancer. Service has the, just like our load balancer, we configure our load balancer, that load balancer know what our backends are. We have an IP to the load balancer, and load balancer has all the visibility of the nodes which it will load balance. So the service module has its own IP address, and it has the IP address of all the pods which it needs to communicate. So if the pod is destroyed and recreated with a different IP address, the service knows the IP address of the newly created pod, and it will communicate with that. So it is done automatically, and we don't need to know the IP address of our pods. The service will take care of it. So now if we communicate with the service names, if even our database container is crashed and recreated, whatever that IP address is assigned to that container, we don't care. We just know that we will communicate through our service and the service will take care of the backend load. Are we getting it? So service, we have external service and internal service. The internal service is like when our application is talking to our database. You don't need, nobody is coming from outside this cluster and talking to our database. But anybody from outside can come and it will connect to our application, because application is the front end and database is the back end. So application definitely needs to connect to database to pull some data or to write some data. So the internal communication is done through the internal service and external communication is done through external service. So we have further two categories, external service and internal service. We will discuss that everything in detail and practically. Okay. Service listens on IP address and the port, but the user is browsing the website with the domain name. The service do not understand the domain name, so we have another component which is called ingress. So anyone who is browsing your website, the request will first go to ingress. It forwards it to the external service. The external service will forward the traffic to your app. Your app using your internal service will go to the database. I think I need to draw this on board. Let's go a bit forward and then we can recap it. So ingress can be configured to communicate with domain name instead of IP addresses. So the request goes to ingress sends it to service, and service will definitely talk to our database through our internal service. Okay. Config map. Let's say this is our pod, and pod is talking to our database, my database. My database can be MySQL. The name can be MariaDB. But what if our database is changed and the name is changed? What we need to do is, if you remember, while configuring our application, in the connection string, we define that the database host will be, let's say, MyDB host, or actually my host or MyDB. We define that in our application because application, when it will be connecting to database, it will need to know the database IP address or the name. Let's assume if my database name is changed here, the name of the service is changed here due to some reason, if we have two versions or anything like that. So we need to build our application again with the new service name. If it is, of course, you have to build all your pods again. You have to do the deployment again because your database connection is changed. So your application is changed, application is updated. You have to pull that everything again. So what we do is, we have another module, config map. We define the database host or database URLs here. We define the database username, database password, and everything here. So our application will come to the config map. It will check the database host, and the database host will have this database configuration available. So if we need to change the database name, we will just change it here, and we don't need to change it in our application. Okay, secret. What is secret? We have another component named secret. And the word secret shows that secret stores data. Passwords are encrypted in base 64. And just like deployment, secret is also connected to a pod. So when we will do it, then you will know it. It's a complete flow. Client wants to browse abc.com. So the request comes to ingress because we are browsing with the domain name. Ingress forwards it to external service. External service forward it to your pod, service pod. Service pod need to connect to database. So it will load some parameters that the database username is the database host, the database username, the database host name. That's it. And the config map will load some values from secret. And we have the IP address, we have the username, and we have the password, and everything will be used by this pod to communicate with the database using internal service. Okay, so we were discussing we have a pod, the very basic unit. The pod has an IP address 192.168.50.60, whatever is the IP address. And we have our app inside this. App is what? It is running on our container. And that's why Kubernetes has Docker engine running inside it. So this is the IP. Let's say we have another pod.
Does the pod has its own IP address?
Every pod has its own IP address. So this is my DB, and it has its own IP address. .10.20. It's managed by the cluster. These IPs are assigned randomly by the Kubernetes. We don't have control over it. The problem is if this pod dies and created again, this IP will change. We know in our application we had index.php. In that we defined that our connection string is the DB host was, let's say, my DB. So it will search for my DB, and we can attach a service here and a service here. And we can name that service my DB. So service, I defined you what is service. Service is a load balancer. And what is a load balancer? Load balancer is like we discussed with when we were discussing the LAMP stack and Nginx as load balancer or reverse proxy. We know that load balancer has some IP address. And if something goes to the load balancer, it takes the request and forwards it to the backend server. It doesn't matter how many backend servers we have. We just have to tell the load balancer that you need to go to these backend servers, right? You should unmute your mics so that I know are you getting it or not. Otherwise, if we are not communicating, I don't know you are getting or where you are confused. So if you don't have any background noise, so you can unmute yourself. Till here we are clear?
Yes, yes.
Okay. So the same thing is with this MyDB service. So now if my application will search for MyDB, so the MyDB is present here. So it will communicate to this MyDB. Actually, MyDB is some IP address 10.20.20.20, and this will send it to our backend pod. Why we are using the service module? Because the pods, when destroyed, they have a dynamic new IP address, and that thing is managed. That communication is then managed by the service module. The service has the complete visibility. If new pod is created, it knows this is my pod and I need to communicate with it. So this is the service module. Then service has two types: external service, internal service. If this app needs to talk to this database, it is internal service and we have to define it internal. If someone from outside needs to connect it, it will connect it like http : the IP address 10.10.10.10 port 80. So this will be external service, and this is our internal service. So while talking about external service, so this service need to be exposed on a node level. We have a node. Node is like a physical server. So till it is communicating inside, we are not talking about anyone from outside the node is coming to it. If outside the so someone from outside the node is coming from it, the node can have an IP address of 192.168.16.147. So let's say if someone is coming from outside, so it might be hitting this IP. This IP will take it to this IP. This IP will take it to the service, and service by using internal communication or internal service will talk to the database. So the service has IP and the port, but the service do not understand the domain names like xyz.com, abc.com. So we have the other module, which is ingress. Okay. So the request will come to ingress. Ingress will define ingress as that if this domain comes to it, let's say abc.com is coming to it, you can go to the external service on this IP address. Because the external service do not understand the domain names. So for that, we have another component, ingress. Now, we are talking about config map. Let's say, I was saying, if this name is changed, this is, let's say, MyDB, it can be now MariaDB. And MyDB is no more available. But your app, your pod, we have uploaded a pod, Apache PHP pod on Docker Hub. If we download that pod, the DB host will search for MyDB. And MyDB is not here. We have another database, MariaDB. So what we can do is there is another component which is called config map. So in config map, we define the database host. It can be MariaDB, or it can be MySQL. So we will tell our pod, whatever is there, you need to connect to it. Let's say we will not define it MariaDB or MySQL, we will define it MyDB. And when this backend is changed, we will tell that you can connect to this, or you can connect to MariaDB service. You can connect to this. If the backend name is changed, we don't care, because we are referencing MyDB here with MyDB. And on the backend, we are changing the pod names and everything. Plus, there are further advantages that we will define the username, the password, and everything here in the config map. Username, password, URL, whatever. The problem is with config map that we have config map, which is actually a clear text file. So we have another module, which is called secret. And secret is attached to a pod. Config map is also attached with the pod. So whenever we are creating our pod, we are telling our pod, let's say I'm creating my this pod. I have a secret file attached to it. I can say configure the MariaDB with the username. What will be the username? Take the value, whatever is the encrypted value, decrypt it. And if you remember, while configuring Docker, we were setting environment variable database username, database password, admin username, admin password. So it will take the parameters from this secret file. The secret file is encrypted in base 64. It will take the parameters from this file, decrypt it, and apply inside this Docker container. So that's how our clear text, the config map is available with the when we push our container to the or someone is using this this configuration, so it will not know what the secret file is and what's the password in there. So we don't transfer secret file everywhere. Okay, we will continue right now. When we will do it practically, maybe we will understand more. These are just the concept what ingress does, because when we are defining the parameters, when we were defining the APIs, when we will be defining config map, just remember that we have config map, we define variables in config map. We have our service, which is internal or external. We have ingress. Why we use ingress? For domain resolution. So this is just now, this is enough. Ingress for name resolution, external service if you want to communicate to external world, internal service, the service which is used for communication inside. And pod, every pod has its own IP address. Pod can be created and destroyed like that, and it always has a different IP address. And to solve that problem, we have a load balancer sort of thing, which is called the service. And let's go on the PowerPoint presentation again. Okay, our complete flow is done. Here I am just telling you that we have worker node 1. It's coming into. We have traffic coming in. So the service, our pod can be created on this physical worker node or on this physical worker node. So we can have 2 pods available. And that is managed by our Replicaset parameter. We have at least one Replicaset. I mean, if I have our application, we can have a replica of our application. And in our configuration, it is so easy that in our configuration, I just write, I will have replica set is equal to 10. I will load my configuration and 10 replica sets will be created automatically. So scale out is so easy. You just need to tell the in YAML file, I need 100 replicas, and it will create 100 pods. If the load is increasing, okay, you can say now make it 200. You just write the word 200, load the file, and it will create 200 pods for you. And if the load is reduced, so you can say, okay, now just do it 10. I need just 10 replicas now. So it will destroy everything, and you will have just 10 pods available. And you don't need to configure any load balancing. Service will manage everything. If you have 100 pods, 100 IPs, service will know those 100 IP addresses. You don't need to do anything on your load balancer. So deployment. What is a deployment? The file we are creating to deploy our pod is called deployment. It's actually the blueprint. We define everything in our deployment that, okay, I will be deploying Nginx pod, I will be deploying Apache pod, I will be deploying this will be the name of this pod, this will be name of this service, and it is the we want this much replica sets. So this is actually the blueprint of your application. And by configuring this file, you can scale up, scale down, or everything is defined here. StatefulSet. The pods can be stateless or stateful. The stateless, our web servers are actually stateless, and our databases are stateful. So if we are configuring a replica set or replication of our stateful application, that is a bit complicated and tricky and tedious. But mostly by default, we are going with the stateless, and our application is, the web servers are stateless because we are not locking or unlocking the tables here. We are just writing or reading the file. That's it. So this is a very basic overview. We will know when we will start implementing it. This is the theory because we need to know the theory, otherwise we will not get it. So Kubernetes architecture. Kubernetes architecture is divided into two main components: the control plane and the worker nodes. The control plane manages what should go where, what pods needs to go where, how much load is there. So every management decision is done on the control plane, and the worker nodes, they do the actual work. I mean, actually the pods are running on the worker nodes. Okay, so as the pods are running on the worker node, so we should have Docker engine running on it. We have another application called Kubelet. It will manage work like creating containers, everything. Services will handle the networking, and kuproxy. Okay, kuproxy, optimization of which request goes where. What does that mean? Kuproxy. I have tried to explain everything. So our pod is running on this worker node. On this worker node. Our database may be running on this host also, and it can have a replica available on this host also. So the load balancer doesn't care which, it will just serve maybe round robin, maybe whatever it is doing. So the kuproxy will make sure that if this pod needs to talk to this pod, or I mean, it will do it through service. So it will tell or make sure that the traffic will remain inside this pod. I mean, we have multiple pods scattered across all the nodes. So if one pod needs to communicate on the other to the other pod, and that pod is both pods are available on the same node, so the traffic should not go east west. It should remain inside the physical boundaries of the host until and unless it is necessary that it goes out. Otherwise, there will be so much traffic storm that your network will choke. So kuproxy is kind of smart load balancer that it is managing the traffic flow. That's it. I told you before, on our worker nodes, we have Docker engine running, we have kubelet running, and we have kuproxy. Kuproxy is like the forwarding engine. It just manages which traffic goes where efficiently. The main thing is this kubelet. It receives the request from the master node, and master node will tell it, okay, just spin a pod, spin a container, spin a pod, and it will just receive a request and creates the pod. So all the worker nodes have kubelet available. They receive the request from the scheduler running on the master node, and it will create your pod. That's it, and your pod is running. Now the master nodes. Master node has a very, very, very important component, which is called API server. Every request, every parameter, every file which we are giving to the Kubernetes goes through here. Validation is done here. We define, okay, we are using this API version, whatever. So it will validate the syntax. Everything goes through this API server. This is very important. And we have different APIs for different modules. For service module, we will see it later. The scheduler. The scheduler decides where to start the pod, on which worker node. It has the visibility of how much resources are utilized on what worker node. So it will decide, okay, spin it in on node 10. So it will send the kubelet process of node 10 that create this pod, and that pod will be created. So it is the duty of scheduler. So the controller manager detects the pods, like if pod died. If you, let's say in your config map, or sorry, if your blueprint in your deployment, you said that there should be 10 pods running, and let's say one of the pod is crashed. So the HCD is a database. It has record of everything. So the controller manager will be always comparing the state of what's in HCD and what's actually running. So let's say in HCD, we have 10, the 10 pods should be there, but there are 9 running. Somehow one pod crashed. So the controller manager detects that change, and it tells the scheduler that please create another pod so that the state should be consistent, or I mean the state should be where it should be. So whatever I am doing, client sends the request to API server, it receives it, validates it, and it forwards it to the scheduler. The scheduler receives the request and see, okay, let's say I need to create a pod. So where it should be created. So it will, API server will send it to scheduler, and it will send the request to kubelet on any of the worker nodes that, okay, spin a pod. That's what scheduler does. And it is running on the master node. The controller manager, okay, it sees if the pod is failed on a worker node, if it is died, if it is crashed. So the controller manager will detect the change, and it cannot create the pod. It will just tell the scheduler, okay, create one pod, and it is the job of scheduler to run a pod on any of the client machine. And as I told you, it is the database which has everybody talks to this. The scheduler talks to HCD, the API server talks to HCD, the control manager talks to HCD. It is the brain. It has everything. So all the decisions are taken on the master node using this HCD.